Okay, so we've just been doing the inverse matrix and we looked at how to find them manually with just a 2x2. So if we had something like this or something, we learned how to manually work out the inverse. Now, if you don't need to show any of that, we would just put it in the calculator and would raise it to -1 to find that on our calculator. So you can see here, they just defined it, so they just typed it in and told the calculator to remember it. But we could have just in here typed that matrix, and this is probably what I would have done, and raised it to the -1, and I'd get this is the inverse matrix. So if you remember, when you have an inverse, so if I have an inverse matrix, really what it looks like is it looks like this. That's what's actually happening. And remember, we said it's like dividing, isn't it? So the way we divide in matrices is we times by the inverse. So you might want to write it. So timesing by inverse is how you divide in matrices. Now, why do I write that? Because that's going to help me solve problems that they give me where I know a couple of matrices, but I don't know the other. So if you have a look down here they're saying A plus X equals B. So what we're saying when we're giving you scenarios of if you had this set up, and what we're saying is that X is going to be the one you don't know, and A is like you know, and B is like you know. Now, if I wrote a little equation like this, if I had 3 plus X equals 5, you would solve it by going X equals 5 minus 3, wouldn't you? Isn't that what you would do? You move the 3 on the other side. Do you remember doing all that? Yeah? So you move that on the other side, and it becomes -3. So this would be the same if you had this scenario down here with your matrices. If I didn't know X here, the one I don't know X here, the way I would solve it is I'd bring the A on the other side and I would subtract it. So I've got that here. That's how I would solve it. So because this one was the one I didn't know, but I know those two, that's how I could work it out. All right, so then it's the same. Then we had another similar pattern where we had X minus A minus B. So what I'm saying is you don't know that one, but they've given you those two in the question. They said matrix X minus this other one that you know equals B. So how would I solve it? So if I moved this over the other side, it becomes plus, doesn't it? Yeah? So that would be how I would solve it. Now, what happened if I had, I'll give you an example for this one. So here, what we're saying, so remember X is the question that you don't know. So if I did an example of that, that could be like if I had 7 times and I had X, Y, Z, and P. So see how I don't know what's in that matrix, that's letters, and I said equals A, which I might say is, 5, 2, 1, 3. So see how the 7 is multiplying here, isn't it? So if I want to divide, that's how I would do it. So how I would solve it is I'd times it by 1/7. So what I'd do is times this 5, 2, 1, 3 and all that. So I'm doing opposite operations. So that one's okay because it's just a scalar, just a number. Then you finally get down to these ones down here, and here is where I have a matrix times another matrix. So this one's the question. I don't know what this one is, but I know that. Now, if I went to move, this is times in here. So if I move it over an equal sign, it's going to divide, isn't it? Yeah? Now, there's no actual dividing in matrices. I said it before. What do? We times, yeah, by the inverse. So can you see here, the way I solve it is by using the inverse matrix and I times it by B. That's like dividing. Okay, so every time you think, if I need to solve something, Now, can you see here with the one that we don't know is after the A? Can you see that there? So it goes A, something we know, X. So can you see, because the A is in the front, it's in the front here. Now, note that it's different in this one. See how the one we know is after the one we don't know? And can you see that the inverse is used after? So that's important. So it depends which way it's set up. So let's go practice some of these and I'll show you what we're talking about. But this might help you in a more complicated questions where you do have the tools to work it out. You just have to know these things. So you can use this little template. Remember, here is that scenario, isn't it? Yeah? That's that scenario. So the way I'm going to solve it. All right, so we are going to use simultaneous equations and we're going to solve them using matrices. So they're going to ask you to set it up with matrices. We know you can solve them using your calculator other ways, but we want you to use it matrices. So say, for example, you've got this in matrix form. They want you to set up these two equations. So, for example, that could be, I'll put an example one up here to help you. So it could be 2x plus 5y equals 8. I'm just making these up. 5x minus 2y equals 16. All right, so say it's like that. You've got two equations. What you're going to do when you set it up in matrix form, so in matrix form, these guys will look like this. What you do is you put the numbers that are in front of the letters in a matrix like that. So this is all the numbers in front of x, and this will be the numbers in front of y. So if I do my example up here, it would be 2, 5, 5, negative 2. Can you see that? I'm putting all the numbers there. And then what we do is you say times, and you put your unknowns. So we don't know what these x and y is, yeah? So you put it like that. Now make sure that, see how I have x and y going across that way, and x and y have to go down that way then, yeah? If you say x first, it go on top in that other matrix. All right, so then what do you think? I'm going to say it equals something, and it's going to be a 2 by 1. What do you think it equals? Looking at this, what do you reckon it looks like? What am I going to put in here? E and F, yeah? So this one up here, when I'm setting it up, it will still have x and y, and what's this one going to equal? 8 and 16, good. So that is me setting up simultaneous equations in matrix form. Now see, if I just labeled this matrix, I'm going to label this one as matrix A. I'm just giving it a name. I'm going to call this one X, and I'm just going to call this one E for the end in matrix. Now can you see up here, so if I did the same up here and I did A, and I call this one X and that one E. Are you happy to say, if I just summarize the little statement like that, can you see we have numbers for A, don't we? We know what that one is. Is that true? We know what that one is. In my little example, it's 2, 5. I don't know what X and Y is, do I? No. But I know that I've got numbers in that one. Is that true? Yeah. So which is the only one I need to know what the numbers actually stand for? The X and Y one. This one here, isn't it? Now, if I quickly just flick back, I want to bring this over the other side. It's multiplying here. I want to divide. So that means I'm going to use the inverse, which is why here I'm using the inverse. So in the end, the way you solve it using matrices is you'll do this, and this is the part you'll put into the calculator. You'll put that matrix to the power of -1 times the E1, okay? So, and that's what you can do. Now, if it's saying provided the determinant of A, so this one at the front doesn't equal 0. If that equals 0, the determinant of that, you can't get an inverse, didn't we? We practiced that. So that means these equations They never have a spot where they solve. And so that's what that means. So we'll just practice. So if you've got, so we just did an example of equations that had 2. So we've done that up here. If you have ones where you have 3 equations, and can you see there's 3 unknowns there? You'll set it up like this. So I'll help you. You won't get much bigger than this. So let's work it out. So you'll have all the letters, all the numbers that are in front of the letters will go in the front matrix. And then you'll times it by X, Y, Z, and then it'll equal all the answers, which is J, K, L. All right? Let's go do a real one, a practice. I'll just pause it and let people write that. All right, so let's do this one together as an example. Okay, first of all, they often ask you to set up these equations in matrix form. So we'll go, this is matrix form. And I might write the word set up so you understand that you're not solving it as such. This is just how it's set up. So what I'm going to do, I've got 3 equations. So my first matrix, and I've got 3 X, Y, and Z are the unknowns. So these 3 equations, I'm going to put the numbers in front of X, Y, and Z. So in the first equation, what's the number in front of X? Yep, 3. What's the number in front of Y? And what's the number in front of Z? Good, -2. Then I'm going to do 2, 3. Now, is there a Z in that second one?
0.
There isn't. There's no Z there, is there? So, as Jake said, we're going to put a 0. Okay, what about this last one? What's the number in front of X there?
1.
Good. If there's nothing, you know that's a 1. This is a 2, and that's a 3. Then what I would do is I do times. What are the letters that are going to go? It's going to be our column matrix, and it's going to go X, Y, Z. Good. And then I'm going to say it equals. What's it going to equal?
5, -5, -1, 3.
Good. And 3. Okay. So that's how you would set it up. Now, if you had to solve using matrices, what we're going to do, what you'll see is you're trying to solve for this one, X, Y, Z. What it's going to equal, it's going to be this matrix here, but the inverse of it. So how do I make that one the inverse? Using my calculator, what would I do? Good. So I'll raise that to the power of -1 and times it by this last one. And that's how you solve. So essentially what you're putting in the calculator is just this bit here to work it out. And I've shown you over here. So can you see this matrix here? Can you see it's this one? Yeah? And then we've raised it to the -1. And if you just do that in steps, it would equal this. So this one is the inverse matrix. You can either do it step by step or you just do it all in one go. So then what happens, you times that inverse matrix, the inverse, by this last one, and then you get your answer. So for us, when we solve this and you're writing it out, in the end you have X, Y, Z, and you've worked out it equals this matrix here. So if you know that, what are you saying X is equal to? What do you think that means? X is what? What is the number there?
3.
X is?
-1.
Excellent. -11. What is Y? 7. And what is Z? 0. Sorry, that's about 0. Okay? And that's how you solve it. So you always have your calculator and you can use it. Just be really careful reading the questions because sometimes they want you to set it up. Sometimes they might want you to show this inverse matrix first. Or sometimes they just want you to solve it straight away. So off you go. You can do it like that. Let's see what else I've got. This is another one. This is an exam question. So this was a Year 12 question because you are capable of doing the Year 12 questions. We're teaching you. Year 12, all it does is add little bits of difficulty in terms of traps, but the theory is still the same. So it says that matrix equations below represent a system of simultaneous linear equations. One of those equations could be, can you see, when we set it up, didn't we go, it was like this, wasn't it? So really, it would have been 2x plus y, and there's no z, equals 3. Is not that how you would have got that in the first one? Yeah? And the second equation could be this, couldn't it? It could have been, there's no x, so I could have said negative 3y plus z equals 2. Good. And then this last one would have been like that. So what would that would have been? Negative x plus 2z. There's a 0 in the y. And it equals? Now, is any of them in our answers? Just this combination? 2x, no. So I'm going to get, that's not it. This one is, isn't it? Is B one? Isn't it that one? Yep, so there's your answer. One of these equations is, and there's an answer. Got it, sweet. Done. All right. So that's why you sort of need to know all the bases. How is it worked out? How is it found? Because that one, they're not asking you to solve it. They're asking you how was it set up. So unless you know how you do it, you wouldn't be able to do that. They know your calculators. All right. Now let's do this one. I'm just going to zoom in a little bit. So the four matrix equations below each represent simultaneous equations, and you can see that they've set it up. The number of these equations which have a unique solution. When it says unique solution, that means they can be solved simultaneously. And what you are looking at, and if they can be solved, it means that the inverse can be found, and therefore the determinants, if it can be solved and have a unique solution, the determinants will not equal 0. So what's a quick way of working out whether these have a unique solution is just to work out their determinants. So if you look at their determinant, remember it's this number by this minus that number by that. So you get 2 by negative 1 minus 1 by negative 2. What will that equal? That'll be negative 2 minus a minus, which becomes plus 2. So is that one? That one is 0. So this one has no unique solution. Okay, so not that one. So let's do this one's determinant. It will be, you tell me, what is it? 6 by 1 minus, good?
2 by 3.
Yep. Yep, that's okay. So we've got 6 minus 6, what's that equal? So has this got a solution or not? No unique solution, whatever. Let's do this determinant down here. What will it be? It'll be 3 by, running out of room there. It'll be 3 by 4 minus 2 by 6. What's that going to equal? 0? Does it have a unique solution? No. Okay, and then this last one would be 1 by 1 minus 1 by 1. What's that? 0.
So the answer is 0.
So how many have a unique solution? None of them. So that's A. Yeah. Remember that next year, Jake, that you said that was easy. All right. So question 3, let's do this one. The basketball coach has written 3 linear equations. Linear just means what you'll get. They've just got the letters in there. There's no powers on the letters, is there? No? No like squared terms or anything on the letters? So if there's only just letters, it means linear. So you don't need to get your knickers in a knot about anything. That's all that means. And you're not going to have to worry about anything other than linear. All right, so which can be used, so they've made these 3 simultaneous equations, and they said that they can be used to predict the number of points, rebounds, and assists in this next basketball game. So they said these equations can be written in matrix form, so you just need to fill in what's missing. So what should go in this missing matrix at the front here? This one here, you have to put the numbers in. So what goes in there? What's the number in front of this one? Yep, 1, 1 and 1, good. So we've got P, R and A going across here. What about in the next equation? It's what?
2, -1.
2, -1 and?
3.
And the last one?
1, 2, 1.
Good. Done. Simple. Now the matrix can be solved by the following. So this matrix here is the inverse. Yeah? They've put it to the power of -1. Okay? So determine x. So how do I find out x? I'm going to put this matrix here into the calculator. 1, 1, 1, 2, -1, 3, 1, 2, 1. I'll type that into the calculator and I'll raise it to -1. And what you're going to get this matrix here, but you're going to be able to see this missing one. So go do that. I'm going to pause it. And so we put this in the calculator and we have found that we got all of that, but we got -5 here. So we know that x is equal to -5. How many rebounds is Oscar predicted to have in the next game? So what you need to really do is solve it now. So you're trying to solve it. So finish that. Okay, so when we actually do this and we've put -5 in here and we solve it, we end up with it equaling 19, 10 and 4. So they want how many rebounds? Which number is the R? That middle one. So how many rebounds will he get the next game?
0.
10. That's a 10.
What? Where?
Yeah. All right.